You hear the word psychosis, and what's the first thing that pops into your head? For most of us, it's schizophrenia, right? But what if those symptoms are just the tip of the iceberg? What if they're actually pointing to something much deeper, an underlying medical condition? Well, today we're diving headfirst into that very idea, exploring the fascinating world of secondary psychosis, and we'll be using the incredible book Secondary Schizophrenia as our guide.
Okay, let's get right into it. We are about to unravel a central puzzle in psychiatry, which is figuring out how to tell the difference between a psychosis that seems to start in the mind and one that's actually a symptom of a disease happening somewhere else in the body.
So, right off the bat, here's the big question. When someone experiences psychosis, can we just automatically assume it's a primary psychiatric disorder like schizophrenia? As we're about to find out, the answer is a huge, resounding no. To really get this, we've got to get our terms straight. On one side, you have primary psychosis, think schizophrenia. We see it as a disorder of how the mind works, but there isn't one single medical test or cause we can point to. But on the other side, you have secondary psychosis. Here, the symptoms are a direct result of another illness. It's like seeing smoke and knowing there's a fire somewhere else you need to find. And this is where things get really interesting. This distinction basically turns clinicians into detectives. They can't just treat the symptoms they see on the surface. They have to follow a trail of clinical clues that might lead them to a completely unexpected culprit.
So how do they build a case? Well, it kind of boils down to three key lines of questioning. First, it's all about timing. Did the psychosis start after the medical condition showed up, and does it get better or worse as that condition changes? Second, do the symptoms themselves seem off? Do they look different from classic schizophrenia? And third, they have to rule out a simpler explanation. For instance, if there's a really strong family history of schizophrenia, that might be the most likely answer, even if another medical issue is also present. And these atypical symptoms are the big red flags. We're talking about things like the psychosis starting much later in life, or severe confusion that you just don't typically see. Another huge clue is when hallucinations involve multiple senses, not just hearing things, but seeing and feeling them too. And then there are these very specific, strange symptoms, like Capgras syndrome. This bizarre delusion where a person believes a loved one has been replaced by an identical imposter. Even smelling things that aren't there can point directly to disease in a specific part of the brain. All right, so we know what clues the detectives are looking for. Now let's see where that trail can lead. Once the investigation points towards an underlying cause, we often find ourselves looking at genetics. So let's check out a lineup of the usual suspects. First up, we've got a condition you may not have heard of, but trust me, it is a huge player in this story. Velocardiofacial syndrome, or VCFS for short. VCFS is caused by a tiny, tiny piece of chromosome 22 going missing. Now get this, it's estimated to affect about 2% of all people diagnosed with schizophrenia. That is not a small number. It happens because this deletion removes one of two copies of about 35 different genes. Think of it like trying to build a complex piece of furniture with only half the instruction manual. This state, called haploinsufficiency, is what messes with development. And as you can imagine, finding this diagnosis has massive implications, especially when it comes to family planning and genetic counseling. Okay, our next suspect is one you've probably heard of, Huntington's disease, a truly devastating neurodegenerative disorder. While most of us associate Huntington's with its terrible effects on movement, psychosis is actually a very common part of the disease. And what's really fascinating is how it presents. It's often preceded by what's called a delusional mood, this vague, deeply unsettling feeling that something is just wrong. It's from that mood that the more classic delusions and hallucinations start to emerge. That, plus a profound sense of apathy, paints a very distinct picture. And believe me, the list of genetic culprits does not stop there. The rabbit hole goes way, way deeper. We see psychosis pop up in a whole bunch of other genetic conditions. You've got storage disorders like Niemann-Pick, where the body can't process certain fats correctly, leading to buildup and damage in the brain. Then there are mitochondrial disorders, where the very power plants inside our cells are faulty. This can cause a whole cascade of problems, from psychosis to diabetes. And then you have other super rare neurological disorders too. It is a really complex landscape. So, we've identified the whodunit, all these different genetic glitches. But what about the howdunit? I mean, how does one tiny genetic error actually cause something as profound and complex as psychosis? The answer seems to lie in this powerful idea of disconnection. And that right there is the real prize. This quote really says it all. By studying these rare genetic disorders that mimic schizophrenia, we can learn fundamental truths about the biology of psychosis itself. These rare diseases are like a Rosetta Stone for understanding the brain.
So the leading theory, and it's a big one, is that schizophrenia, whether it's primary or secondary, is a disorder of brain connectivity. Don't think of it as one broken spot in the brain. Think of it as a problem with the wiring between the different regions. The communication lines, the synapses and connections that let our brain cells talk to each other, are faulty. And this diagram, it lays it all out perfectly. This is a model for Niemann-Pick disease. It shows the whole chain reaction. Look at the top. It all starts with a single gene mutation. That one error leads to a cascade of problems inside the cell, like cholesterol getting trapped. Just follow the arrows down, you see nerve growth gets messed up, toxic proteins build up, and what's the final result at the very bottom? Neuronal disconnection and neuronal dysfunction. That's the biological breakdown that ultimately leads to the clinical symptoms of psychosis. It's an incredible roadmap. So, after all this deep dive science, we land on the most important question of all. Why does getting this right actually matter for patients and their families in the real world? The whole thing really hinges on this number, 3%. That's roughly how many new cases of schizophrenia might actually be a secondary psychosis. Now, 3% might not sound like a lot, but think about what it means. We're not talking about a handful of rare cases. We're talking about thousands of people every single year whose entire lives could be changed by getting the right diagnosis.
Because getting it right changes everything. It changes the treatment plan, because you're not just managing psychosis anymore, you might be treating an underlying metabolic disorder. It changes overall health management, because now you know to look for related issues like heart problems or diabetes. It opens the door to absolutely crucial genetic counseling for the entire family. And finally, it completely reframes the prognosis, giving everyone a much clearer, more accurate picture of what the future holds.
Which leaves us with this final thought. We've just seen how a single, tiny genetic mistake can set off a chain reaction that completely rewires the brain's connectivity and leads to psychosis. So it makes you wonder, if one gene can do all that, how many other conditions that we've neatly filed away under one label are just waiting for us to uncover their true underlying cause? The investigation, it seems, is really just beginning.